It is October 2019, and something is wrong with one of the brightest stars in the night sky. Astronomers pointing their telescopes toward the constellation Orion notice that the star marking the Hunter's shoulder is fading and fading fast. Within a few weeks, it has lost noticeable brightness. By the time February 2020 rolls around, the star has dropped to roughly a third of its normal glow, tumbling from magnitude 0, 5, all the way down to 1, 7. For a star that has shone steadily in the sky for as long as human beings have been looking up, this is not normal. This is the kind of drop that makes professional astronomers sit up in the middle of the night and start refreshing data feeds every few hours. The star is called Betelgeuse. And in the weeks that followed that sudden dimming, a genuine wave of panic spread through the astronomy community and then out into the public. Headlines everywhere started asking the same terrifying question: is Betelgeuse about to explode? Because Betelgeuse is not just any star. It is a red supergiant so enormous that if you dropped it into the center of our solar system in place of the Sun, its outer edge would swallow Mercury, Venus, Earth, Mars, and reach out toward Jupiter. More than 400 million suns could fit inside its volume. It sits roughly 650 light years from Earth, which in cosmic terms is basically next door. And it is a star that astronomers already knew was living on borrowed time, a star late in its life, ready at some point to end in one of the most violent events the universe produces, a supernova. So when this famous, enormous nearby star suddenly started dimming in a way nobody had ever documented before, the fear was not irrational. Massive stars like Betelgeuse often do dim before they detonate. Some scientists genuinely began preparing for the possibility that they were witnessing the final months or even the final days of Betelgeuse's life. If that happened, this would not be some faint smudge in a distant galaxy. A supernova at that distance would be visible in broad daylight, casting shadows at night, rivaling the brightness of the full moon for weeks. It would be one of the great astronomical events in recorded human history, and it seemed, for a moment, like it might be happening in real time, right as ordinary people scrolled through their phones reading the news. Consider just how strange this situation was for the people actually running the observations. Telescopes around the world, both professional and amateur, were suddenly turned toward Orion night after night. Astronomers were publicly discussing contingency plans for what a nearby supernova would actually look like from Earth, how bright it would get, how long it would remain visible, and what it might mean for our understanding of stellar death in general, since no supernova this close to Earth had been observed with modern instruments in the history of astronomy. Betelgeuse would have been the closest supernova candidate ever studied with today's technology, and for a few tense months, plenty of serious scientists genuinely entertained the possibility that they were watching the opening act of that event unfold in real time. Then, slowly, the star began to recover. By the middle of 2020, its brightness was climbing back toward normal. The supernova never came. But here's the part almost nobody talked about at the time. This dramatic false alarm ended up cracking open a mystery that had been sitting quietly, unresolved for decades. Because the great dimming of Betelgeuse, as it came to be known, did not just repeat itself for no reason. Later analysis, using the Hubble Space Telescope, suggested that Betelgeuse had essentially blown a piece of itself off. It had experienced a surface mass ejection, hurling a huge blob of hot material millions of miles into space. That material cooled as it drifted outward, condensing into a vast cloud of dust that temporarily blocked our view of much of the star's surface from Earth's vantage point. In other words, the star had not shrunk or gone dark from the inside. It had essentially sneezed out part of itself, and we were staring at the resulting dust cloud, mistaking it for the star fading away. That explanation satisfied one mystery, but it opened the door to a much older, much stranger one, a mystery astronomers had been quietly chasing for years before the great dimming ever happened. Betelgeuse pulses with a fairly reliable rhythm, brightening and dimming on a cycle of about 400 days, like a slow, steady heartbeat. That part was well understood, but layered on top of that heartbeat, astronomers had also detected a second, much longer cycle, one that stretched across roughly 6 years, sometimes measured closer to 5,800 days. This longer rhythm did not behave the way ordinary stellar pulsation should. It was subtle, it was strange, and nobody could fully explain where it came from. For years, researchers threw out theory after theory to explain this so-called long secondary period. Some thought it might be caused by enormous convection cells, gigantic bubbles of hot gas rising and falling within the star, like the surface of a pot of boiling soup, but on a scale that dwarfs entire planets. Others thought clouds of dust drifting around the star might be periodically blocking and unblocking its light as they orbited. Some suspected magnetic activity on the star's surface, similar to sunspots, but on a monstrous scale. And then there was one more theory, one that kept resurfacing in scientific papers for years without ever being proven. What if Betelgeuse was not alone? What if there was a companion star, a smaller partner, quietly orbiting close to the giant, too faint and too buried in Betelgeuse's overwhelming glare for anyone to actually see it? This idea sounds almost obvious in hindsight, but proving it was brutally difficult. Betelgeuse is so bright, and any hypothetical companion would be so faint by comparison, that spotting it directly would be like trying to see a struck match sitting right next to a wildfire. Astronomers ran calculations based on the star's wobbling motion, its radial velocity, and the subtle astrometric shifts in its position. And by the early 2020s, multiple independent research teams had converged on eerily similar predictions. If a companion existed, it would be a relatively low-mass star, somewhere around 1 to 2 times the mass of our Sun, locked into an extremely tight orbit, circling Betelgeuse roughly once every 6 years, on a path tilted almost exactly edge-on as seen from Earth. Some models even predicted this hidden companion was orbiting so close to Betelgeuse that it was not simply near the star. It was believed to be orbiting inside the star's enormous outer atmosphere, a region of gas so vast and so extended that it stretches far beyond what most people would consider the visible surface of a normal star. Think about what that actually means for a moment. Betelgeuse is so monstrously large that its atmosphere alone, the thin, wispy outer layer of gas surrounding it, extends out into a region that would be considered a legitimate planetary orbit around a normal star. And astronomers were suggesting that somewhere out in that ocean of gas, a second, smaller star might be swimming through it like a fish through water, completing full laps around its giant neighbor every 6 years, drenched the entire time in the outer breath of Betelgeuse itself. It helps to understand just how long Betelgeuse has been under human observation before any of this was even suspected. This is a star that sits in one of the most recognizable constellations in the sky, easily visible to the naked eye across nearly every inhabited part of the planet. Ancient civilizations tracked its reddish glow long before telescopes existed. And once telescopes did exist, Betelgeuse became one of the very first stars whose actual physical disk astronomers managed to resolve, rather than seeing it as a simple point of light. It has been measured, remeasured, photographed, and modeled for well over a century. And yet, despite all of that scrutiny, despite being one of the most observed, most photographed, most written about stars in the entire sky, nobody had the faintest idea that a second star might be tucked inside its atmosphere until relatively recently. That alone should tell you something about how difficult this particular discovery actually was. For years, this remained a compelling but unconfirmed theory, an educated guess dressed up in mathematics. Every attempt to directly photograph this hypothetical companion using space telescopes came back empty. Betelgeuse's glare was simply too overwhelming, and the predicted separation between the two stars was too small for existing instruments to resolve. Researchers needed something smarter than simply pointing a bigger telescope and hoping. That breakthrough came from an unexpected place. Rather than relying purely on space-based telescopes, a scientist named Steve Howell at NASA's Ames Research Center realized that a powerful ground-based telescope might actually have an advantage here. He turned to the Gemini North Telescope in Hawaii, an 8-meter giant paired with a specialized high-resolution camera nicknamed Alopec. This instrument works using a technique called speckle imaging, which involves capturing thousands upon thousands of extremely short exposure images and then digitally processing them to cancel out the blurring effects of Earth's atmosphere. It is a clever workaround, essentially outsmarting the atmospheric distortion that normally makes ground-based observations blurrier than those from space. Before this, teams had already tried and failed using powerful space-based observatories on the assumption that avoiding Earth's turbulent atmosphere entirely would give them the cleanest possible view. That assumption turned out to be wrong, or at least incomplete. Space telescopes came back with nothing, the predicted companion simply too faint and too close to Betelgeuse's blinding glare to separate from the giant star's light using those instruments. It took a large ground-based telescope, paired with a technique originally developed to defeat atmospheric blurring, rather than avoid it altogether, to finally crack the problem. Sometimes the more expensive, more exotic tool is not automatically the better one, and this discovery is a genuine example of clever technique beating raw telescope size. In December 2024, Howell's team pointed this instrument at Betelgeuse, timed precisely to coincide with the moment their models predicted the hidden companion would be at its greatest separation from the giant star, the easiest possible moment to catch a glimpse of it. And there, sitting exactly where the mathematics had predicted, was a faint blue glow, a companion star, staring back at them for the first time in recorded human history. The detection was faint, roughly 6 magnitudes dimmer than Betelgeuse itself in blue light, separated from the giant by a mere 52 milliarc seconds, an almost impossibly small angle on the sky. But it was there. Early estimates suggested this newly glimpsed companion was a hot, young, blue-white star, not yet old enough to be fusing hydrogen in its core the way mature stars do. Its mass appeared to be somewhere around 1.5 to 1.6 times that of our Sun, and it appeared to be orbiting at a distance of only about 4 astronomical units from Betelgeuse. For context, that is closer than Jupiter orbits our own Sun, an almost absurdly tight embrace for two stars, one of which is hundreds of times larger than the other. Naturally, this discovery needed a name. Researchers had been informally calling the hypothetical companion Beetle Buddy for years, a nickname that stuck around in scientific talks and press briefings, simply because it was catchy. But for something this significant, scientists wanted something a little more fitting. Betelgeuse's name traces back to Arabic, generally translated as referring to the hand or shoulder of the giant. So the team proposed naming the newly glimpsed companion Siwarha, an Arabic word meaning her bracelet. The imagery is almost poetic, a giant, and wrapped tightly around its wrist, a small glimmering companion, orbiting so close it might as well be jewelry. There is something worth pausing on here too. Siwarha itself is not some cold, dead husk of a star. Based on its estimated mass and its blue-white color, it appears to be a genuinely young, hot object, one that has not even begun fusing hydrogen at its core the way a fully mature star does. In stellar terms, it is essentially still an infant, or at least an adolescent, caught in the earliest stages of its own life, while orbiting inside the dying outer layers of an ancient giant that is somewhere near the very end of its own life cycle. Two stars at opposite extremes of their respective lifespans, locked together in the same tight orbital embrace, one just getting started and the other already approaching its final act. When this detection was announced in the summer of 2025, it was treated as a landmark moment, the missing piece finally clicking into place after decades of speculation. But there was an important asterisk attached to it. The scientists themselves were careful to describe this as a probable detection, not an absolute ironclad confirmation. The signal was faint, right at the edge of what the instrument could reliably measure. It matched the predictions almost perfectly, which was extremely promising, but a single faint blue smudge next to an overwhelmingly bright star was not quite enough to close the case entirely. Astronomers wanted stronger, more direct proof. They wanted to see this companion actually doing something, actively interacting with Betelgeuse, leaving fingerprints of its presence that could not be explained any other way. That proof arrived only a few months later, and it came from a place nobody expected, not from a sharper photograph, but from watching the gas itself move. A team led by astronomer Andrea Dupre at the Center for Astrophysics, Harvard and Smithsonian, had been quietly gathering data on Betelgeuse for nearly 8 straight years, using NASA's Hubble Space Telescope alongside ground-based observatories, including the Fred Lawrence Whipple Observatory in Arizona and the Roque de los Muchachos Observatory in Spain. Rather than trying to photograph the companion directly, this team focused on something more subtle, tracking tiny repeating changes in Betelgeuse's spectrum, the fingerprint of light that reveals the speed, direction, and density of gas moving through the star's outer atmosphere. What they found, once they laid nearly a decade of observations side by side, was extraordinary. Every 6 years, right around the moment the companion was predicted to swing in front of Betelgeuse from our point of view, the spectral data revealed a dense, disturbed trail of gas expanding outward from the giant star. It looked exactly like the wake left behind a boat cutting through water, except this wake was being carved not through an ocean, but through the outer atmosphere of one of the largest stars in the visible sky. The pattern repeated with uncanny precision, appearing right on schedule, orbit after orbit, exactly matching where a companion plowing through that gas should leave a disturbance. To be clear about why this mattered so much, a single photograph, even a real one, can sometimes be misleading, a trick of light, a processing artifact, a coincidence of timing. But a repeating physical signature, showing up at the same predicted point in the orbit year after year across nearly a full decade of independent observations, is a different category of evidence entirely. It is the difference between spotting a shadow once in the dark and watching the exact same shadow fall in the exact same place every single time the sun reaches the same position in the sky. This was the smoking gun scientists had been chasing for years. Not just a faint dot in a photograph, but direct physical evidence that something solid was moving through Betelgeuse's atmosphere, dragging a trail of disrupted gas behind it like a speedboat leaves ripples spreading across a lake. Dupree and her colleagues published these findings in January 2026, describing it as the strongest, most direct evidence yet that Siwarha is real, and that it is actively colliding with and reshaping the material surrounding Betelgeuse. Dupree herself put it simply, noting that the idea of an undetected companion had been gaining popularity for years, but without direct evidence, it remained an unproven theory. Now, for the first time, there was hard proof that a hidden companion had been sitting there all along, right where nobody could quite manage to look before. So, let's sit with what this actually means, because it is stranger than it first sounds. This is not simply a case of two stars near each other in space, casually orbiting like a normal binary system. Siwarha is not orbiting outside Betelgeuse the way Earth orbits the Sun, comfortably separated by empty space. It is orbiting so close, and Betelgeuse's atmosphere is so enormous that the companion star spends its entire existence physically submerged within the outer layers of its giant neighbor. Every single orbit, it plows directly through Betelgeuse's extended atmosphere, dragging visible trails of disturbed gas in its path. Picture a small boat trapped permanently inside the outer mist of a massive waterfall, circling endlessly, never able to leave the spray behind. That is essentially the relationship between these two stars. And this arrangement is not stable forever. Because Siwarha is constantly moving through thick stellar material rather than empty vacuum, it experiences drag, a kind of cosmic friction slowing it down bit by bit with every single pass. Scientists estimate that this process will eventually cause the companion's orbit to decay entirely, spiraling closer and closer inward until, within roughly the next 10,000 years, Siwarha is completely swallowed by Betelgeuse. 10,000 years sounds like an eternity in human terms, but in the lifespan of a star, that is essentially tomorrow. Somewhere out there, a small, young, blue-white star is quite literally living inside the final act of a much larger star's life, doomed to eventually be consumed by the very atmosphere it has been swimming through for millennia. This discovery does far more than simply satisfy curiosity about one unusual star. It reshapes how astronomers understand Betelgeuse's entire behavior. Remember that mysterious 6-year-long secondary period that puzzled scientists for decades? That rhythm now appears to be a direct signature of Siwarha's orbit, the giant star's light subtly shifting each time its hidden companion swings around and disturbs the surrounding gas. Even the puzzling spin rate of Betelgeuse starts to make more sense in this light. Without a companion, models suggest Betelgeuse's rotation should be almost imperceptibly slow, taking roughly 100,000 years to complete a single spin. Yet observations show it spinning noticeably faster than that. The presence of a close, gravitationally interacting companion, tugging and tidally influencing the giant star over time, may be exactly what is spinning Betelgeuse up faster than it otherwise would be. This also completely reframes the great dimming event that started this entire panic back in 2019. Researchers now suspect the dramatic dimming may not have simply been a random burst of mass ejection happening in isolation. It occurred suspiciously close to the timing predicted for Siwarha's orbit, raising the intriguing possibility that a burst of ejected material from Betelgeuse's surface collided with a pre-existing trail or shell of gas already being dragged along by the orbiting companion. In other words, the very event that made the entire world briefly believe Betelgeuse might be exploding may itself have been triggered, at least in part, by the hidden companion we didn't even know existed at the time. It is worth pausing here to appreciate the layers of irony stacked on top of each other. A star briefly panicked half the astronomical community into thinking it was about to explode. That panic sparked a wave of intense observation. That observation eventually revealed the star had blown off a piece of itself, forming a dust cloud. Investigating why that dust cloud formed exactly where and when it did eventually led scientists back to a decades-old, previously unconfirmed theory about a hidden companion star. And chasing that theory down finally produced direct proof that a second star has been quietly living inside Betelgeuse's atmosphere the entire time, invisible to nearly every telescope ever pointed at it, until very recently. There's also something almost unsettling about the timeline involved here. Betelgeuse itself is expected to eventually explode as a supernova, ending its life in one of the most powerful explosions the universe produces. Nobody knows exactly when this will happen. It could be tomorrow, astronomically speaking, or it could still be tens of thousands of years away. What this new discovery adds is an entirely new wrinkle to that eventual finale. Somewhere in that same general time frame, possibly even before Betelgeuse explodes, its hidden companion is expected to spiral inward and be consumed entirely by the giant star's atmosphere. Two dramatic cosmic endings, potentially converging within the same relatively narrow window of time, playing out in a system that ancient civilizations have been staring up at with the naked eye for thousands of years without ever suspecting any of this was happening. And that ultimately might be the most striking part of this entire story. Betelgeuse is one of the most studied, most photographed, most written about stars in the entire night sky. People have tracked its slow, steady pulsing brightness for centuries. Ancient astronomers charted it. Modern astrophysicists have poured enormous resources into studying it. And despite all of that attention, despite all of that data, there was a second star hiding in plain sight this entire time, tucked so deeply inside Betelgeuse's own atmosphere that it took a purpose-built imaging technique and nearly 8 years of painstaking spectral analysis just to prove it was really there. Scientists are already looking ahead to what comes next. With Siwarha's existence now strongly supported by direct evidence, researchers want to refine exactly how massive it is, exactly how tightly it is bound to Betelgeuse, and exactly how much longer it has before being swallowed entirely. There's also enormous scientific value in what this teaches us about other massive stars across the galaxy. Betelgeuse is one of the very few red supergiants close enough and bright enough for scientists to study this way in this level of detail. Many other stars showing similarly strange long-term brightness variations may be hiding companions of their own, quietly orbiting inside their outer atmospheres, waiting for someone with the right tools and enough patience to finally notice. It is also worth remembering how young this entire chapter of the story really is. The first faint photographic hint of Siwarha only appeared at the end of 2024. The announcement of that probable detection only reached the public in the middle of 2025. And the far stronger, far more convincing wake evidence only became public in January 2026, mere months before this very story is being told. In other words, this is not some settled, decades-old textbook fact being casually revisited. This is one of the freshest confirmed discoveries in modern stellar astronomy. A mystery that has genuinely been cracked open within the last couple of years, after remaining unsolved for the better part of a human lifetime. Millions of people have looked up at Betelgeuse throughout their entire lives without ever knowing that a second star was quietly orbiting inside its atmosphere the whole time. And in a very real sense, we are among the very first generations of humans to actually know the truth about what that faint reddish light in Orion has been hiding. For now, Betelgeuse remains exactly what it has always been to the naked eye. A bright, faintly reddish star glinting from the shoulder of Orion, visible from nearly anywhere on Earth on a clear night. But the next time you look up and spot it, know that hidden within that soft, reddish glow, buried inside the star's own extended breath, there's a second, smaller star silently completing its doomed orbit, dragging a visible wake through the giant's atmosphere every 6 years, spiraling ever so slowly toward an inevitable ending. A quiet, hidden companion that stayed completely invisible for as long as human beings have been watching this star, only to finally reveal itself the moment we panicked enough to look closer than we ever had before.